Very good morning to all of you. So today we'll try to understand some numericals on three-phase fully controlled rectifier control. So basically in this question you can see the you are having the motor, that is a three-phase motor is there, and when you are going for three-phase, when the power rating is greater than 10 kilowatt, then in that case you will have to go for a three-phase fully controlled rectifier. So you can see here a 220 volt. This is the armature voltage. This one is the armature voltage. Now this one is the rated speed and this one is the rated current. Armature resistance is 0.5 ohm. Now the available AC source voltage has a line voltage. Now you can see that the available source voltage is this is the 440 volt, and between the two lines you are having this 440 volt. You can see here. Then it is fed to a star delta transformer. So one is the star delta transformer. This is the star one. Then on the secondary side you are having a delta. Secondary side you are having a delta, and this delta is feeding this control rectifier. This delta is feeding the control rectifier, and the control rectifier voltage will be given to a DC motor. Fine. In this way you can draw this. Okay, this one is the thing. I think we have drawn. Now a DC motor. Now a DC motor. So this one is RA, then this one is LA, and then you are having the back end. Fine. So this is the arrangement for the three-phase fully controlled rectifier. So now what is to be evaluated, that is the turns ratio. Now turns ratio means what? Turns ratio means N1 upon N2. Fine. This one is the source side and this one is for the secondary side, or you can say the load side. So N1 means what? V1 RMS. Fine, V1 RMS upon V2 RMS. Fine, V1 RMS, because the turns, that is the number of turns, will be decided by the voltage which you are applying on the turn, which you are applying on the insulation, you can say. So this one V1 upon V2 should be there, but you are having a three phase, and so I think you will have to go for the phase values, but the line value is given. So the line value is only given for the source side, not for the what you can say, not for the load side. Only the source side is available. So I think source side will be what? A star connection is there, and you know that in a star connection, phase value will be equals to phase value in star connection, phase value will be equals to line value upon root 3, line value upon root 3 for a star connection. But for a delta, the phase value will be equals to phase value of voltage, I'm saying, not the current, phase value of the voltage, to be precise. Phase value of voltage will be equals to line value of the voltage. Fine. So by using this concept, we will calculate the turns ratio. So the turns ratio, this is V1 RMS. I think the first one, the source side is the star one, and this is V2 RMS. So V1 RMS means how much? V1 RMS 440 upon root 3, but I think V2 RMS is not given. So how to calculate? So to calculate the V2 RMS, something is given. So what is given? A star delta transformer is used to feed the armature so that the motor terminal voltage equals the rated voltage when converter firing angle is 0. So I think in this case, some hidden concept is there. So what is the concept? The VA will be equals to 3 Vm upon pi into cos of alpha. Fine. So how to calculate? I think this is the motor terminal voltage, that is VA. So motor terminal voltage will be equals the rated voltage where converter firing angle is 0. So I think how to calculate this one? So motor terminal voltage. This is VA. Fine. So I think you will have to calculate the VM. Motor terminal voltage equals the rated voltage. Rated voltage means what? That is how much? 220, na? Motor terminal voltage equals the rated voltage when converter firing angle is 0. So only then, because this Vm is what? Vm is the peak value of Vm is the peak value of the secondary side. Fine. This is not for the primary side because you have separated this source and the load with a transformer. This is an isolated converter, we can say, and the isolated converter is feeding a DC motor. So in this case, you don't have to calculate VM for the source side. And please don't write VM as 440 into root 2, or you can say 440 upon root 3 into root 2. So this VM is related to the secondary one. So in that case, VM you will have to calculate, because ultimately our aim is to calculate the V2 RMS. No, fine. So to calculate the V2 RMS, the condition is given. That is, a motor terminal voltage equals the rated voltage when the converter firing angle is 0. Right. So now, okay, so everything is known to you now. So Vm will be, so this is the Vm. Vm will be equals to pi into Va upon 3 into cos of alpha. So 3 into cos of alpha. Now pi into VA. VA is how much? VA is 220 volt, 220 volt into 3 into cos of 0, because the converter firing angle is 0 and the motor terminal voltage equals the rated voltage. This is the rated voltage. So after calculating this, so what is the value? So Vm will be equals to 230.38. This is the peak value we are saying, but we want the RMS one. Now, how to calculate the RMS? So V2 RMS. So V2 RMS will be equals to Vm upon root 2. So that is 230.38 upon root 2. So what is the value? 162.9. So 162.9. So if you just put down the values, you are going to calculate this 440 upon root 3 upon this is 162.9. So in this way, you can calculate the turns ratio. This is the concept you will have to remember. And whenever such things needs to be obtained, then some conditions should be given in your question. Fine. Now determine the value of firing angle when motor is running at 1200 rpm. Again the same question, because you will have to calculate the firing angle. So the speed is given. Speed is given. Then what is the first thing you have to find? That is the back EMF. After finding the back EMF, then the armature voltage. Armature voltage, from the armature voltage, you can calculate what? Alpha. Fine. And this is at the rated torque. The torque is rated means what? Torque is rated. Torque is rated. So IA2 will be equals to IA2 will be equals to IA. Now what is IA? 50 ampere. Now you can see here, when the motor is running at minus 800 rpm, the speed is given. This is for the braking operation, and twice the rated torque. It means that the IA3 will be equals to double. IA3 will be equals to IA, that is 50 twice into IA, to 2 into 50, that is 100 ampere. So I think we have already discussed this, the same thing in the single phase. So by using the same concepts, you have to calculate the things. Okay? So I think we'll just directly go to the solution side. Where is the solution side? This one, right. This one is the solution side. You can see, I'll rub the things for you. I'll rub the things for you. The questions are with you. You can just read the question and directly come to the solution side. So alpha needs to be calculated. This is the rated motor torque. IA will be equal to 50 ampere. But before that, you will have to calculate the back EMF for the rated operation. For the rated speed, I'm saying. For the rated speed, I'm saying fine, because the speed has changed, and for the change speed, you will have to calculate the firing angle. Fine. So E1 will be equal to VA minus IA into RA. All the things are given. The rated armature voltage is there. Then the armature current is there. So E1 will be equals to 195 volt. Now after this, what is the next thing? What is the next thing? That is the E2 now, because the speed has changed, that is 1200 rpm. So E2 will be equals to 1200 upon 1500 into 195. So 156 volt will be the back EMF for the changed speed. Again, I am saying. Now, after this, because we want to evaluate the alpha, and for evaluating the alpha, terminal voltage is required. Fine. So VA2 will be equals to A2 plus IA into RA. So if you put down the values, the 181 volt will be the answer. Fine. Now this is the three phase. So the formula will be 3 Vm upon pi into cos alpha. Okay, we are just assuming the continuous conduction. We have not assumed here discontinuous conduction. The voltage value will be changed for a discontinuous conduction. Fine. So this one is the answer. Alpha will be equal to 34.65. Now similarly for the braking one, but here the torque is doubled. When the torque is doubled means what is doubled? When the torque is doubled, T will be equal to K phi into IA. When the torque is doubled, this is the constant. This is the separately excited one. Nah? This is the constant. So it means that the motor current is doubled. Fine. When the torque is doubled, it means the motor current is doubled. So IA will be equals to 2 into 50 into 100 ampere. So in this way, you can go for the firing angle for the braking operation. Fine. This is all about the three-phase fully controlled rectifier. Thanks a lot.